Hi everybody, in this video I'm going to show you how to do a hypothesis test for a population proportion. And to do that we're going to be using the z-test for population proportions, and we'll be using the graphing calculator to do that. The z-test for a population proportion is a statistical test to basically try to estimate how a population of people feel about something. And basically, just like with confidence intervals, we should only use the z-test only if the sample size times the proportion is greater than or equal to 5. And the same thing for when the sample size times its complement, q, is greater than or equal to 5. And the complement, remember, is just 1 minus the proportion. And these things are very easy to test, but you're not going to have to do those for the homework. Every problem that will be given to you will assume that the sample will assume NP is greater than or equal to 5 and NQ is greater than or equal to 5. The test statistic that you'll use is the sample proportion, which is P with the hat on it, and then the test statistic or standardized test statistic that you're going to use, is called a z-statistic. And basically that is calculated as, for the numerator, the sample proportion minus the hypothesized population proportion, which is just regular P. And it's going to be divided by the standard error, which is the square root of the population proportion times its complement, and both of those are going to be divided by the sample size. The nice thing is, like everything else we've done, the z-statistic formula is basically already in the graphing calculator, so all you need to do is give it the pieces of the puzzle and it'll solve for z for you. So when you're doing a proportion test with the graphing calculator, just like with means, you're going to state your null and alternative hypotheses first, your HO and your HA. You're going to specify the level of significance, that's the alpha level, that'll be given to you in your problem. Determine the critical values. You can use the normal table for this, because basically with proportions, it's based off of the normal distribution. However, there's also a website link that I would recommend instead. It's a little bit easier to use and less cumbersome than Table 4. And those critical values will determine your rejection regions. Afterwards, you're going to find the standardized test statistic, that's your z value, and then sketch it on the normal curve. And then basically, if the z value that you calculate falls in the rejection region, you reject HO. The HO is no mo. Otherwise, you fail to reject HO. And then you make a decision based on the claim, your original claim. And same as before with the means test, the alternative approach to this is comparing p-values to alpha. Graphing calculator will give you the p-value of the hypothesis test, and basically if you want to compare that p-value to the alpha level and do it that way, that's totally acceptable. So here's a problem. A research center claims that less than 50% of US adults have accessed the internet over a wireless network with a laptop computer. In a random sample of 100 adults, 39% say they have accessed the internet over a wireless network with a laptop. At an alpha level of 0.01, is there enough evidence to support the researcher's claim? So at the bottom, they've shown you that they've calculated to make sure that the proportion test is appropriate. So they took the sample size, which was 100, and multiplied it by the hypothesized proportion, which was 0.5. Gives you 50. That's definitely bigger than 5. Well, the complement of 50%, Q, is also 50%. So 100 times 50% is also 50. So basically, we've met the condition that it's okay to use a hypothesis test. And like I said, you can excuse yourself from doing that on the homework. So basically, what they're telling us here, we hypothesize that less than 50% of adults access the internet with a laptop. So that less than 50%, if we had to write that mathematically, you use a letter P to represent the population proportion, and we're seeing less than, the less than sign, then 50%, which is 0.5, is a decimal. So essentially, they've given you your HA statement. So let's switch to the next slide. So our claim here is HA. We think the proportion is less than 50%. The null hypothesis, or HO, would be the exact opposite of less than, which is greater than and equals, because HO always has the equal sign. In our problem, they told us the alpha level is 0.01, and now let's figure out our rejection region. So let me pause the video for a second. So I'm on the UB Learns homepage, and I'm going to go and click on course documents to show you the critical value calculator. And then I'll scroll down to critical value calculator, and then pick the second option, the proportion test critical value calculator. It takes you to this web page, and basically for a normal distribution, which is what we use for the proportion test, all you need to tell it is the alpha level, and then whether or not you're doing a left-tailed, the less than test, a right-tailed or greater than test, or a two-tailed not equals test. And that's it. That's all you need to do, and it'll shoot out the appropriate critical value. So in this problem, we said the alpha level was 0.01, and our HA was the less than test. So it's a left-tailed test. And then hit calculate. And if we scroll down, it says the Z critical value for the left-tailed test is negative 2.33. So there you go. It actually even puts the negative sign there, so there's no worries there. So let's switch back to the PowerPoint and just make sure they come to the same conclusion that we did. Okay, and basically they did. So here's our normal curve, and there's our shaded rejection region. So basically, the Z statistic that we get in our graphing calculator has to be more negative than 2.33 in order for us to reject the null hypothesis. And by rejecting the null hypothesis, that supports our claim that the proportion is less than 0.5. So let me hit the arrow. And basically, if we plug this stuff in by hand, so 0.39 represents the sample proportion, 0.5 is the hypothesized proportion we think it is, divided by the square root of our hypothesized p, which is 0.5, its complement, which is also 0.5, divided by 100. Basically, we get we get a standardized test statistic of negative 2.2. And if we see on the normal curve here, that test statistic we found of negative 2.2 is just shy of being in the rejection region. So close but no cigar. So in other words, we have to fail to reject the null hypothesis. In other words, at an alpha level of 0.01, we do not have enough evidence to support the claim that less than 50% of U.S. adults have accessed the internet over a wireless laptop computer. So let's double check in the graphing calculator, make sure we get the same thing. So to do the hypothesis test in the graphing calculator, hit the stat button, arrow over to the right for tests, and we're going to go down to the one prop Z test. P0 represents our hypothesized proportion. This is the value we used in our hypothesis statements. So we're comparing everything to 50% or 0.5. Going down, X represents the people that have actually accessed the internet. And they told us in the last slide, just to backtrack, they said that was 39%. Well, I need to know how many people 39% is. So that's literally going to be the percentage, it expresses a decimal, so 0.39, multiplied by the total sample size, which they told us was 100 people. So really 39% of the sample is 39 people. And N represents the sample size, that's 100. And then lastly, what type of hypothesis test we're doing depends on HA. And that's the less than test. So arrow over to the less than, hit the enter, and then go down to draw and hit enter. And it's going to sketch our normal distribution. So there's Z, that's our standardized test statistic. They told us is negative 2.2, which is the same as if we had done this by hand. And the p-value here is 0.0139. So we can only reject the null hypothesis if the p-value is less than alpha. Well, looking at it, it's very close. 0.0139 is pretty close, but it's not smaller than 0.01. So therefore, I don't have enough evidence to reject the HO. So in other words, I haven't proven that I have enough evidence to support my claim that less than 50% of adults have accessed internet over a wireless network. Here's another problem. A research center claims that 25% of college graduates think a college degree is not worth the cost. You decide to test this claim and ask a random sample of 200 college graduates whether they think college is is not worth the cost. Of those surveyed, 21% reply yes. At an alpha level of 0.1, is there enough evidence to reject the claim? So they're saying here we think that 25% is the proportion. So in other words, our HO statement is we think the proportion P equals 25%. So switching over to the next slide, that means that if we think the true proportion is 25%, that means the alternative would be that it's not 25%. And our alpha level is 0.1, they told us in the problem. Let's double check and see if we can get those same critical values that they did in their slide. So it's a two-tailed test because it's not equals. So let's switch. Our alpha level was 0.1, and it's two-tailed, so we'll hit calculate. And scrolling down, it says the Z critical values are negative 1.64 and positive 1.64. We get the same answer. So let's plug our data now into the graphing calculator. Hit stat, arrow over to test, the one prop Z test. Okay, our proportion of interest we think is 25%, 0.25. That's the proportion we use in our hypothesis statements. Okay. We asked 200 people, that's our sample size, 200. And they told us in the problem 21% of those people feel college is not worth the cost. So that's 0.21 multiplied by the sample size of 200. That means 42 people in the sample said they don't think college is worth the cost. And then lastly, go down and say not equals, hit enter here, because we're doing a two-tailed test. That's what our HA statement is. Then go down to draw and hit enter. And we can see here that here's our Z critical value, not Z critical value. This is our Z test statistic on the left, which is negative 1.31. And our p-value on the right is 0.1914. So the test statistic, the standardized test statistic, clearly does not fall in the shaded rejection region here. So that's evidence that we don't reject the null hypothesis. But if we use the p-value approach, the p-value of 0.19 is way bigger than the alpha level of 0.1. So we can't reject the null hypothesis for that reason either. So any way we look at it, we have to fail to reject HO. That means that at an alpha level of 0.1, and it looks like there's a typo here, there is not enough evidence to reject the claim that 25% of college graduates think a college degree is not worth the cost.